Hello there, and welcome to the Sleep with Science channel. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps the channel to reach more curious minds like yours. Now let's begin. Close your eyes for a moment, and imagine the last light of Earth slowly shrinking behind you until it becomes nothing more than a pale blue dot, swallowed gently by the endless dark. Somewhere beyond the orbit of the moon, beyond the reach of every radio signal, beyond the last whisper of sunlight strong enough to warm a human hand, a question begins to form, quiet and heavy, like a stone sinking into still water. How long could we, fragile creatures of warmth and breath and heartbeat, actually survive out there, alone, in the vast and silent ocean of deep space? It sounds like the beginning of a story, doesn't it? But it is also one of the most profound and unsettling questions in all of science, because everything we are, every cell, every breath, every steady rhythm of our sleeping bodies, was built here, cradled by this one particular planet, tuned perfectly to its gravity, its atmosphere, its gentle magnetic shield. Take us away from that, even by a few 100,000 miles, and the universe stops being beautiful and starts being something else entirely. It becomes indifferent, cold beyond imagination, radiation-soaked and silent. And yet, humanity has always been drawn toward that darkness, not despite the danger, but almost because of it. We are the only species we know of that looks up at a sky that could kill us in seconds, and feels not fear first, but wonder. Tonight, as your body settles and your mind begins to loosen its grip on the day behind you, we are going to drift together into that question, slowly, gently, the way a spacecraft drifts once its engines fall silent. We will not rush toward answers. We will let them arrive the way starlight arrives, traveling for years, sometimes centuries, before it finally reaches something capable of noticing it. So let your shoulders soften. Let your breathing slow, and let your imagination begin its quiet ascent, past the clouds, past the thin blue veil of atmosphere that has protected every single heartbeat that has ever existed, and out into the great and patient silence beyond. To understand how long we could survive in deep space, we first have to understand what deep space actually is, and how strange it becomes the moment you truly leave home behind. Low Earth orbit, where astronauts aboard the International Space Station drift a mere 250 miles above the surface, is not deep space at all. It is more like standing on a balcony overlooking your own house. The station still moves within Earth's magnetic embrace, still shielded from the worst of the sun's fury, still only minutes away from rescue if something goes wrong. Deep space begins somewhere beyond that comfort, beyond the magnetosphere's protective bubble, in the region where the Apollo astronauts once ventured on their way to the moon, a mere 250,000 miles away, and yet already a place where the radiation levels rise sharply, where the silence becomes absolute, where a human body is no longer being gently held by its home planet but simply exposed, floating, alone. Beyond the moon, beyond the inner solar system, distances stop making intuitive sense. Mars, at its closest, is still tens of millions of miles away, a journey of many months even at the highest speeds our current engines can manage. And beyond Mars lies the asteroid belt, then the gas giants, then the long, cold emptiness of the outer solar system, where sunlight becomes so faint that even at Jupiter, 5 times farther from the sun than Earth, daylight would look like a deep and heavy twilight. Keep drifting, and eventually you reach the edge of the sun's influence altogether, a boundary called the heliopause, where the solar wind finally gives way to the vast interstellar medium beyond. Voyager 1, humanity's most distant emissary, crossed that threshold in 2012, and it took decades of travel to get there. It is, even now, still moving outward, carrying a golden record of human sounds and music into a darkness so complete that scientists sometimes describe interstellar space as colder than anything found naturally on Earth, hovering just a few degrees above absolute zero. This is the environment we are asking the human body to survive within. Not a metaphor. not a poetic exaggeration. An actual physical reality of extreme cold, extreme radiation, and extreme distance from any rescue, any resupply, any voice that might answer back. And yet, before we can talk about survival, about oxygen and radiation shielding and the slow psychological weight of isolation, we first have to sit with the sheer scale of what we are discussing, because scale is where this question truly begins. Scale is what makes the difference between a short walk outside and a journey from which there may be no return, and it is precisely there, in the immensity of that distance, that our story of survival must begin. Distance in space is not measured the way we measure distance on Earth, not in miles that a car could cover in an afternoon, not even in the thousands of miles that separate continents. It is measured in light, in the time it takes the fastest thing in the universe to travel from one point to another, and even then, the numbers grow so large that they slip past ordinary understanding, the way a dream slips away in the moments after waking. Light itself, moving at roughly 186,000 miles every single second, takes just over a second to reach the moon from Earth. It takes about 8 minutes to reach us from the Sun. It takes over 4 hours to reach the outer edges of the solar system where Voyager now drifts. And to reach the very nearest star beyond our own Sun, a small red companion called Proxima Centauri, light needs more than 4 years of uninterrupted travel. Let that settle for a moment. Light, the fastest possible traveler in existence, needs 4 years to make a journey that, for a human spacecraft using our current technology, would take tens of thousands of years to complete. This is the true shape of the emptiness we are discussing tonight, not a void that is simply far away, but a void so vast that our fastest machines crawl through it like a single grain of sand inching across an entire desert. And within that emptiness, the human body becomes something almost unbearably small, almost impossibly delicate, a warm and breathing anomaly surrounded on all sides by conditions that would end it within moments if even one thin layer of protection were removed. Consider, for a moment, what actually keeps you alive as you lie here now, listening, drifting, safe beneath the atmosphere without even realizing how much labor that safety requires. Earth's atmosphere presses down upon you with a very specific and very necessary weight, roughly 14 pounds of pressure on every square inch of your body, a pressure so constant and so familiar that you have never once had to think about it. Yet it is this pressure that keeps the fluids in your body in balance, that allows your lungs to draw oxygen in a way your cells can actually use. Remove that pressure suddenly, expose a human body directly to the vacuum of space without protection, and the results are almost immediate. Within about 15 seconds, oxygen deprivation would cause loss of consciousness, as the near total absence of pressure causes gases dissolved in blood and tissue to begin forming bubbles, a condition similar to what deep-sea divers fear when they surface too quickly, except far more severe and far faster. Saliva on the tongue would begin to boil, not from heat, but from the simple physics of pressure, because liquids boil at lower temperatures when there is less pressure holding them down, and in a true vacuum, there is essentially no pressure at all. Skin would not explode, as old films once imagined, because it is elastic enough to contain the body's shape, but within roughly 90 seconds, without immediate pressurization, the damage would become unsurvivable. This is why every spacesuit, every capsule, every inch of the International Space Station exists as an act of defiance against the vacuum, a small stubborn bubble of Earth-like pressure carried out into an environment that offers absolutely none of its own. And pressure is only the first problem, the most immediate one, the one that would end things fastest. Beyond it lies an entire landscape of slower dangers, quieter dangers, the kind that take not seconds but days, weeks, months, even years to fully reveal themselves, dangers that would shape any real attempt at long-duration human survival far from home. Temperature, for instance, behaves strangely in deep space, in ways that seem to contradict the popular image of a universe that is simply uniformly cold. In direct sunlight, without an atmosphere to filter and diffuse that light, surfaces can heat to well over 200 degrees Fahrenheit, hot enough to cause severe burns within moments of contact. Yet step into shadow, Even a shadow cast by something as small as a spacecraft's own hull, and temperatures can plummet to hundreds of degrees below zero almost instantly, because without an atmosphere to hold and circulate heat, there is nothing to soften the transition between blazing exposure and absolute cold. A human body drifting freely in deep space would experience this extremity not as day and night the way we know it, but as a razor's edge between fire and ice, separated by nothing more than the width of a shadow. And then there is radiation, perhaps the most insidious danger of all, because unlike the vacuum or the temperature extremes, radiation does not announce itself with immediate and obvious symptoms. It works quietly, cumulatively, invisibly, altering cells, damaging DNA, increasing the risk of cancer and organ failure over months and years rather than seconds. Earth's magnetic field, that invisible shield generated deep within our planet's molten core, deflects the vast majority of this radiation before it ever reaches the surface, which means that every human being who has ever lived, until the very recent dawn of the space age, has spent their entire life inside a kind of natural fortress without ever knowing it was there, and it is only now, as we begin to imagine journeys beyond that fortress, that we start to understand exactly how much protection that fortress has quietly provided us every single day, without a single moment of gratitude required. Out beyond the magnetosphere, in the open reaches of interstellar space, radiation arrives in several distinct and patient forms, each with its own particular danger, each moving at almost unimaginable speed toward anything soft enough to absorb it. There is radiation from the sun itself, streaming outward in what scientists call the solar wind, a constant hush of charged particles that occasionally erupts into violent storms capable of overwhelming even the most careful shielding. And there is a second, deeper kind of radiation, one that does not come from any single star at all, called galactic cosmic radiation, born in the shock waves of exploding stars scattered across the galaxy, supernovae whose light reached us long ago but whose particles are still arriving now, and will keep arriving for as long as the galaxy exists. These particles move at nearly the speed of light, and unlike the solar wind, they are extraordinarily difficult to block, because they are so energetic that they can pass directly through several inches of aluminum, through the walls of a spacecraft, through skin and muscle, straight into the delicate machinery of a living cell, where they can sever strands of DNA the way a thread might be severed by something impossibly fine and impossibly fast. A single astronaut spending 6 months aboard the International Space Station, still nestled safely within Earth's protective magnetic field, absorbs roughly the same radiation dose as several hundred chest X-rays. Now imagine removing that protection entirely, sending a body out past the moon, past the reach of Earth's magnetic embrace, into months or years of open exposure. The numbers begin to climb into territory that no human body has ever been asked to endure, not once, not in the entire quiet history of our species standing beneath this one particular sky. And yet, despite all of this, despite the vacuum and the temperature extremes and the invisible rain of cosmic particles, human beings have not simply avoided this question. We have leaned into it, slowly, carefully, curiously, the way a person might lean toward the edge of a great canyon at night, drawn by something deeper than fear. Our species has always measured itself against impossible distances. Long before rockets, long before we understood what a star truly was, ancient civilizations lay beneath these same skies and told stories about the points of light above them, wove them into myths of gods and animals and ancestors, used them to navigate oceans whose edges they could not see. There is something almost inevitable, then, in the fact that once we finally understood what those lights actually were, once we learned that each one was a sun, some far larger than our own, we did not simply admire them from a distance. We began to ask whether we could go there, whether we could survive there, whether the same curiosity that once guided sailors across dark oceans using nothing but starlight could, one day, guide something living across the far darker ocean lying between the stars themselves. This is not a new dream. It is, in many ways, one of the oldest dreams our species has ever carried, quietly folded inside every myth about flight, every story of reaching the heavens, Every child who has ever lain on their back in a field at night and wondered what it might feel like to simply keep going upward, past the clouds, past the moon, past everything familiar, and not stop. But dreams, however old and however beautiful, must eventually meet the discipline of physics, and it is here, in that meeting point between wonder and reality, that the true question of survival begins to take shape. Because it is not enough to ask whether a human being could physically endure the vacuum, the cold, the radiation, for some limited stretch of time, with the right suit, the right shielding, the right careful engineering. The deeper question, the one that keeps drawing scientists and dreamers alike back to their notebooks and their late-night calculations, is how long? Not whether survival is possible for a moment, a day, a week, but whether it could be sustained, extended, stretched across months, years, perhaps even generations, far from the gentle gravity and abundant resources of the only home our species has ever known. To answer that question honestly, we cannot simply talk about suits and shielding, important as they are. We have to talk about air, about the invisible and endless labor of breathing, about how a closed metal container drifting through absolute emptiness might somehow continue producing the one thing every human cell requires without pause, every single moment of every single day, for as long as that journey might last. We have to talk about water, about food, about the strange chemistry of keeping a small, self-contained world alive when the nearest replenishment lies not days away, but years, decades, sometimes lifetimes beyond reach. And we have to talk, too, about something far less visible than oxygen or water, something that has quietly ended missions and broken minds long before any physical system ever failed, the slow, patient weight of isolation, a force so quiet that it rarely announces itself the way hunger or thirst or cold might announce themselves, and yet a force capable of unraveling a human mind with a patience that few physical dangers can match. Think, for a moment, about how deeply human beings are wired for presence, for company, for the sound of another voice answering back within a reasonable span of time. Even here on Earth, in the most remote and isolated outposts we have ever built, researchers stationed through the long winter darkness of Antarctica, submarine crews submerged for months beneath the ocean surface, have reported strange and telling symptoms once isolation stretches past a certain invisible threshold. Sleep patterns shift and fragment. Time itself begins to feel unreliable, days blurring into weeks without the usual markers of sunrise and sunset to anchor them. Small irritations swell into significant conflicts. And in some cases, something researchers have come to call the overview effect's darker cousin begins to emerge, a kind of quiet detachment, a feeling of unreality, as though the isolated place itself has become the only true world, and everything beyond it, family, friends, the ordinary textures of a life once lived, begins to feel distant, abstract, almost imagined. Now take that same vulnerability, already present in isolated places on our own familiar planet, and place it inside a small metal vessel drifting through the silent dark beyond the moon, beyond Mars, beyond the last comforting glimpse of Earth as anything larger than a single pale point of light among countless others. Communication itself becomes a lesson in patience and distance. A radio signal sent from Mars, at its closest approach to Earth, still takes several minutes to arrive, which means true conversation, the easy back and forth we take entirely for granted, becomes impossible. Every message becomes a kind of letter, sent out into the dark, waiting to be answered, and by the time an answer might return, the moment that prompted the question has already become part of the past. Push that distance further, toward the outer solar system, toward the empty regions beyond, and the delay stretches from minutes into hours, then conceivably into something far longer, until a conversation with home becomes less like speaking and more like sending messages into a void and trusting, quietly, patiently, that someone on the other end still exists to receive them. This is why, when scientists and mission planners speak seriously about long-duration deep space survival, they speak about psychological resilience with nearly the same gravity they reserve for oxygen systems and radiation shielding, because a mind that begins to fracture under the weight of isolation can undo months of careful engineering in a single moment of poor judgment, a single mistake made by hands that have simply, quietly, stopped trusting the world around them. And yet, remarkably, human beings have also shown an extraordinary capacity to adapt to exactly these conditions, to find rhythm and meaning and even peace within environments that seem, on paper, almost designed to break them. Astronauts who have spent extended periods aboard the International Space Station often describe a kind of quiet transformation that occurs somewhere around the 2 or 3 month mark, a settling in, as the mind begins to accept its new and strange environment as simply the environment, the way a person eventually stops noticing the hum of a refrigerator or the weight of a familiar blanket. Some describe finding a new relationship with time itself, no longer measuring days by sunrise and sunset, since the station circles the Earth every 90 minutes, gifting its crew 16 sunrises within a single 24-hour period, but instead measuring days by rhythm, by task, by the quiet discipline of routine. This adaptability, this strange and specific resilience woven somewhere deep into human psychology, may ultimately prove just as important to long-term survival as any physical shielding or mechanical system, because a journey that lasts months, years, perhaps generations, cannot be sustained by hardware alone. It requires minds capable of enduring not just the absence of danger, but the presence of emptiness, the vast and echoing silence that surrounds any vessel small enough to be called home and large enough to hold every remaining piece of a familiar world. And it is precisely because that emptiness presses so heavily against the mind that engineers and scientists have spent decades quietly obsessed with the opposite problem, the physical one, the question of how to keep a fragile human body breathing, hydrated, and fed, inside a sealed metal shell, drifting through a void that offers nothing, absolutely nothing, in return, a question that begins, as so many questions of survival do, with the simplest and most essential act any living creature performs without ever once having to think about: breathing. In the vacuum of deep space, breath becomes a currency more precious than any mineral, any fuel reserve, any communication signal cast hopelessly toward a distant Earth. A human being at rest draws in roughly enough oxygen each day to fill a small room, and exhales in its place a slow and steady tide of carbon dioxide, invisible, odorless, and yet lethal in accumulation, the way silence can become deafening if it stretches long enough without interruption. Every spacecraft designed for extended habitation must therefore become something stranger than a vehicle. It must become a lung. A slow, mechanical, endlessly patient lung, breathing in unison with everyone it carries, scrubbing the air of what the body no longer needs and returning it, cleansed, into the same recycled atmosphere that has already passed through 1,000 other breaths before it. Aboard the International Space Station, this happens through systems with unglamorous names: the Electron, the Sabatier reactor, machines that split water into oxygen and hydrogen using electricity harvested from sunlight, machines that coax carbon dioxide and hydrogen together into water and methane, closing a loop that would otherwise spiral toward suffocation. It is a strange kind of poetry, if you allow yourself to see it that way: water becoming breath, and breath becoming water again, a closed and looping river with no outlet to the sea, circulating endlessly through pipes and filters and the quiet architecture of survival. For a journey to Mars, lasting perhaps 2 to 3 years depending on the alignment of the planets, these systems must not falter, not once, not for the length of a single uninterrupted breath, because there is no atmosphere beyond the hull to fall back upon, no thin margin of forgiveness the way Earth's own sky offers even in its most polluted, most poisoned corners. And yet oxygen, despite its immediacy, its terrifying non-negotiability, is in some ways the easier problem. Water, too, can be recycled with remarkable efficiency. Astronauts today reclaim nearly all of the moisture their bodies release, through sweat, through breath, through the humble and unglamorous processing of what once seemed unrecoverable, until nearly every drop of water aboard the station has, in some form, already been consumed and returned dozens of times over. There is something quietly humbling in this fact, that the water a crew member drinks tonight may carry, chemically speaking, the faint echo of tears shed months earlier, or perspiration from a workout completed in the deep hush of orbital midnight. Nothing lost, nothing wasted, everything folded back into the great slow cycle that keeps a small crew alive far from the world that made them. Food, however, resists this same elegant closure. Unlike air and water, food cannot yet be manufactured from nothing, or recycled from what the body no longer needs, at least not efficiently, not at the scale a mission to the outer solar system would demand. It must be carried, calculated, rationed with a precision that borders on the mathematical sublime, every gram accounted for against the mass constraints of a rocket that must fight gravity itself simply to lift a single sandwich beyond the atmosphere. A single astronaut, over the course of a year, requires close to 1,000 pounds of food, dehydrated, freeze-dried, vacuum-sealed into pouches designed to survive months in transit without spoiling, without succumbing to the radiation and thermal extremes of open space. For a crew of 4 traveling to Mars and back, this calculates into tons of cargo, tons of mass, tons of fuel required simply to carry the food required to carry the crew required to reach the destination in the first place, a recursive equation that seems, at times, almost cruel in its complexity. This is why scientists have begun looking toward more radical solutions: greenhouses grown in sealed modules under artificial light, algae cultivated in bioreactors for their astonishing nutritional density, and even, more speculatively, the eventual dream of growing food directly on the surface of Mars itself, in greenhouses shielded from radiation, using soil painstakingly treated to remove the perchlorates that make the Martian regolith toxic in its natural state. Some experiments aboard the International Space Station have already tested this frontier in miniature: astronauts growing lettuce, radishes, even small batches of chili peppers in specialized growth chambers, tiny green interruptions in an otherwise metallic world, offering not just nutrition but something harder to quantify, a psychological tether to the rhythms of Earth, the simple, ancient comfort of watching something grow. Because even in the depths of engineered survival, even amid the calculations of oxygen ratios and caloric intake and water reclamation percentages, there remains something undeniably human about the act of nurturing life within a vessel built to sustain it. A single sprouting seed becomes, in this context, more than biology. It becomes evidence. Evidence that growth is still possible, that time still moves forward in something other than countdowns and system checks, that somewhere within the sterile hum of ventilation fans and solar array motors, a small green leaf still turns, however faintly, toward whatever light it can find. And it is this quiet, persistent instinct, the instinct to keep something alive, to keep something growing, that mission planners increasingly believe may prove just as vital to survival across the true distances of deep space as any oxygen system or water reclaimer. Because the challenge ahead is no longer simply how to keep a human body breathing for a handful of months, but how to sustain not one body, not one mind, but many, together, isolated, drifting farther from Earth than any human beings have ever drifted before, toward journeys that stretch not across months but across years, and in some proposed missions, across decades, timelines so vast that the very concept of a single, unified crew begins to blur into something closer to a lineage, a small, floating civilization measured not in days remaining until return, but in generations born and raised beneath an artificial sky. Consider, for a moment, the sheer scale of distance involved. Mars, at its closest approach, sits some 33 million miles from Earth, already a distance so vast that a radio signal, traveling at the speed of light, requires several minutes simply to cross the gap, turning even simple conversation into something halting, delayed, stretched thin across the silence between transmission and reply. But Mars, in the grand architecture of the solar system, is close. It is a neighbor, a first step, the shallow end of a much deeper ocean. Jupiter's moons, Europa in particular, with its hidden ocean sealed beneath miles of ice, sit roughly 5 times farther from the Sun than Earth itself. Journeys there measured not in months but in years, even with the most efficient propulsion systems currently imagined. And beyond that, the outer reaches of the solar system, the frozen worlds of the Kuiper Belt, Pluto and its icy siblings, drift so far from the Sun that sunlight itself becomes little more than a faint suggestion, 1,000 times weaker than what falls upon Earth's surface, a twilight that never quite becomes daylight, holding its dim and permanent vigil over a landscape of frozen nitrogen and ancient, undisturbed stone. To imagine human beings surviving in such places is to imagine an almost complete detachment from everything the human body evolved to expect. No sunrise to calibrate the internal clock. No wind, no rain, no gravity pulling blood steadily downward through legs built across millions of years of walking upon solid ground. In these environments, the spacecraft itself must become not simply a shelter, but an entire ecosystem in miniature, closed, self-sustaining, endlessly cycling its limited resources through systems that must run, without failure, 4 years at a stretch, in a void that offers no rescue, no resupply, no possibility of correction beyond what the crew itself can engineer with the materials already sealed inside the hull. This is where the conversation shifts, gently but decisively, from simple survival, keeping bodies breathing and hydrated and fed, into something closer to civilization building, however small in scale. Because a journey lasting years cannot rely solely on stored provisions carried from Earth. At some point, the mathematics simply refuse to cooperate. Mass becomes the ultimate tyrant of space travel, every additional pound of cargo demanding exponentially more fuel to accelerate, decelerate, and maneuver across the vast gulfs between worlds. And so scientists have turned their attention toward the deeper, more difficult question of closed-loop sustainability, systems capable of producing food, recycling waste, and regenerating breathable air indefinitely, without dependence on resupply missions that may, given the distances involved, become logistically impossible. Some proposed designs imagine vast rotating structures, cylinders or torus-shaped habitats spinning slowly enough to simulate gravity through centrifugal force, offering not just psychological comfort but genuine physiological necessity, since prolonged exposure to true weightlessness gradually weakens bone density and muscle mass. A slow erosion that becomes increasingly dangerous the longer a mission stretches beyond the months humans have already tested aboard stations orbiting Earth. Within such structures, engineers envision agricultural rings, farmland folded into curved decks, crops growing beneath banks of artificial light engineered to mimic the specific wavelengths plants require for photosynthesis, an entire greenhouse ecosystem suspended within a metal shell hurtling silently through the dark. And yet, even as these designs push toward greater self-sufficiency, a deeper question quietly persists beneath the engineering diagrams and resource calculations, a question less mechanical, more philosophical in nature. What does it mean for human beings to live an entire life, birth to death, without ever once standing beneath an open sky? What does it mean for a child born aboard such a vessel to know Earth only as a story, a photograph, a blue and distant memory carried forward by parents and grandparents who themselves may have only the faintest recollection of solid ground beneath bare feet, of wind moving through leaves, of rain falling freely from an open and ungoverned sky? These are not questions engineers alone can answer. They belong instead to poets, to psychologists, to philosophers who study not the mechanics of survival but the deeper architecture of meaning, because a mission capable of sustaining a body for decades may still fail if it cannot sustain something less tangible, less easily measured, and yet, in its own quiet way, equally essential. Purpose. Identity. The sense of belonging not simply to a place, but to a continuing story, a lineage that stretches backward toward Earth and forward toward whatever awaits at journey's end, however distant, however uncertain. And so, even as scientists refine the mechanics of closed-loop life support, of artificial gravity, of sustainable agriculture within sealed metal walls, they find themselves circling back, again and again, to the same fundamental truth that shaped this narration from its very beginning, that survival in deep space is not merely a question of biology or engineering, but a question of what it means to remain, in the fullest sense of the word, human, even as every familiar reference point for that humanity slowly falls away behind the ship like light receding into the dark. Consider sleep, that most basic and unremarkable of human acts, something so automatic on Earth that most people never once contemplate its architecture, its dependence on cycles of light and dark that have governed life on this planet since before life itself grew complicated enough to dream. The human body, across hundreds of thousands of years, calibrated itself to a 24-hour rotation, a rhythm encoded so deeply into biology that even in the absence of visible sunlight, even in windowless rooms, even in the depths of caves sealed away from every trace of the outside world, the body continues, faithfully, stubbornly, to search for a day that may no longer exist in any meaningful sense. Aboard the International Space Station, this rhythm survives only through careful, deliberate engineering, artificial lighting cycled to mimic sunrise and sunset, schedules enforced with quiet discipline, because without such intervention, the 16 sunrises that mark each 24-hour orbit would fracture the crew's internal clocks into chaos, a slow unraveling of the very rhythm that allows a mind to rest, to repair, to wake each morning feeling something resembling whole. On a journey stretching years into the emptiness beyond Mars, beyond even the faint dim light of Jupiter's distant moons, this challenge deepens considerably. Sunlight itself becomes negligible, a fact easily stated but difficult to truly absorb, that somewhere past the orbit of Neptune, the sun appears not as a warming presence but as merely the brightest of an indifferent field of stars, offering light too faint to read by, too faint to warm skin, too faint to mark the passage of anything resembling a day. In such conditions, human circadian rhythm cannot rely upon the cosmos at all. It must instead be manufactured entirely from within the vessel itself, artificial light cycling through wavelengths calibrated to trigger the same hormonal responses sunlight once provided freely, melatonin rising in a simulated dusk, cortisol rising gently in a simulated dawn, an entire biological theater performed nightly for an audience of one, or few, or perhaps, across generations, many. And still, even with such careful calibration, something subtler persists, harder to engineer, harder to name. The absence of true darkness, true silence, true stillness that exists beyond the hum of machinery. On Earth, night carries with it an ancient, primal quality, an evolutionary memory of vulnerability and rest intertwined, the settling of the body into the protective embrace of shelter, walls, closed eyes trusting an environment stabilized by billions of years of shared biological history. Aboard a spacecraft, that trust must be manufactured differently, built not from evolutionary instinct but from routine, from repetition, from the deliberate construction of ritual, because ritual, scientists have observed, often succeeds where instinct alone cannot follow. This is perhaps why astronauts speak so often, almost reverently, of small habits carried carefully into orbit, a particular way of folding a blanket, a specific playlist reserved only for the final hour before sleep, a photograph positioned at a precise angle beside a sleeping berth. These are not incidental details. They are, in their own quiet way, survival tools, anchors cast into the vast undifferentiated dark of space, small deliberate acts that recreate, however imperfectly, the sensation of belonging somewhere specific, somewhere chosen, somewhere that remains constant even as the larger environment offers nothing but infinite and indifferent expanse. Psychologists studying long-duration isolation, from Antarctic research stations to submarine crews sealed beneath the ocean for months at a time, have found remarkably similar patterns, that human beings do not simply endure extreme isolation through willpower alone, but through the deliberate construction of meaning within small, controllable spaces. A garden tended carefully within a sealed habitat. A journal filled steadily, night after night, regardless of what the day contained. A weekly call home, however delayed, however brief, treated with the reverence of ceremony rather than mere communication. These rituals, seemingly small against the vast backdrop of interplanetary or interstellar distance, function as psychological ballast, keeping the mind steady even as the body drifts farther from every familiar coordinate it once relied upon. And it is worth pausing here, in the quiet architecture of this idea, to consider how strange and how beautiful it is that survival across such staggering distances may depend not solely upon oxygen generators or radiation shielding, but upon something as delicate as a folded blanket, a familiar song, a photograph angled just so beside a narrow bed suspended in the dark. That the human mind, faced with the largest emptiness it has ever encountered, does not simply surrender to that emptiness, but instead begins, quietly, instinctively, to fill it, piece by piece, ritual by ritual, until even the void itself begins to feel, if not familiar, then at least survivable. It is this same instinct, scientists believe, that will ultimately determine whether human beings can sustain not just months or years in deep space, but something far longer, something that stretches toward the horizon of generations, toward journeys so vast that the ones who depart will never be the ones who arrive, toward missions where survival is measured not in the endurance of a single human life, but in the quiet, careful passing of purpose from one generation to the next, like a flame sheltered and carried forward through a long and otherwise lightless corridor. This idea, once confined to the pages of speculative fiction, has in recent decades become the subject of serious study among scientists and mission architects, who refer to such undertakings as generational or multi-generational voyages, missions in which no single crew member is expected to witness the destination, but instead contributes some portion of a much longer relay, a life lived entirely in transit, bounded on one side by the memory of a world never personally seen, and on the other, by the hope of a world not yet reached. The nearest star system beyond our own, Alpha Centauri, sits just over 4 light-years away, a distance so vast that even light, moving at roughly 6 trillion miles each year, requires more than 4 years simply to make the crossing. For a spacecraft built with current or near-future propulsion technology, this same journey could require many thousands of years, a timescale that dwarfs not just a single human lifetime, but dozens, perhaps hundreds of lifetimes strung together in unbroken sequence. To imagine survival across such a span requires imagining not a single sealed vessel, but an entire enclosed biosphere, self-sustaining across centuries, capable of supporting agriculture, medicine, education, governance, and, perhaps most delicately of all, meaning, across generations who will know Earth only through inherited memory, through story, through the careful preservation of a history that grows, with each passing year, further removed from lived experience. Some scientists have proposed massive rotating habitats, cylindrical worlds turning slowly through the dark, generating gravity through centrifugal motion, their interior surfaces engineered with soil, water, forests, even simulated weather, entire miniature ecosystems folded inside a metal shell built to outlast the individual ambitions of any single generation that calls it home. Within such a vessel, the challenges shift again, moving beyond the immediate mechanics of oxygen and food and psychological ritual, into questions of genetic diversity, since a population too small risks the slow, quiet erosion of health across generations through inbreeding, a problem requiring careful calculation of minimum viable population size, often estimated by researchers to fall somewhere between several hundred and several thousand individuals, depending on assumptions about mission, length, genetic screening technology, and reproductive strategy. It becomes, in this light, not merely an engineering problem, but a profoundly human one, questions of family, of relationships, of how children born mid-voyage might come to understand their own identity, suspended as they are between an origin they will never see and a destination that exists, for their entire lives, only as calculation, as hope, as a number of years remaining on a ship's chronometer. And yet, even within such extraordinary circumstances, certain patterns persist, patterns observed already in smaller, more contained versions of isolation here on Earth. Communities, scientists have found, tend to organize meaning around ritual and rhythm even when the original context for that ritual has long since faded. A ship's culture might develop entirely new traditions unrelated to Earth, festivals marking the anniversary of departure, ceremonies observing key milestones of the voyage's midpoint, oral histories passed down not as static artifact but as living, evolving narrative, reshaped gently by each generation that inherits it. In this way, survival across centuries becomes not simply a matter of maintaining biological function, but of maintaining narrative continuity, a sense that the voyage itself possesses meaning beyond mere transportation, that those aboard are not simply drifting through emptiness, but participating in something larger than any single lifetime could contain. Some researchers, considering these possibilities, have drawn comparisons to the great cathedral projects of medieval Europe, structures whose construction spanned centuries, begun by architects who understood, from the very first stone laid, that they would never witness the completed structure, that the work itself belonged not to them individually, but to a lineage of builders stretching forward into a future they could only imagine. There is, in this comparison, something quietly profound, the suggestion that human beings have, across history, already demonstrated a capacity for exactly this kind of patient, intergenerational purpose, that the instinct to build towards something beyond one's own lifetime is not a foreign concept requiring invention, but an ancient one requiring only translation into a new and unprecedented context. Still, the differences remain significant, and scientists studying the psychology of confinement caution against romanticizing what such a voyage would truly demand of the human mind and body, sealed for generations within walls that, however vast, however carefully engineered, remain finite, remain closed, remain separated by unimaginable distance from the blue and living world that gave rise to every instinct, every rhythm, every quiet longing carried forward, generation after generation, toward a destination that exists, for most of those aboard, only as a story, a promise, a coordinate on a chart, never as a place the light has touched. Consider what this means for a child born in the dim glow of a ship's artificial dawn, somewhere between the orbit of one star system's edge and the black, echoing emptiness beyond. That child will grow up knowing Earth only through recordings, through the careful preservation of images that show oceans they will never swim in, forests they will never walk beneath, a sky that holds no walls, no hull, no hum of recycled air moving through vents engineered by hands 3 generations gone. Psychologists who study isolation, who have watched the slow unraveling that can occur even in Antarctic research stations, even aboard submarines submerged for months at a time, speak of something they call the third quarter phenomenon, a dip in morale and cohesion that arrives not at the beginning of confinement, when novelty still carries its own momentum, and not at the very end, when the promise of release sharpens focus and endurance, but somewhere in the long, undifferentiated middle, when the mind, starved of new horizons, begins to fold in on itself. Now stretch that phenomenon across decades, across centuries. What does a third quarter crisis look like when there is no fourth quarter within any individual lifetime, when the arrival itself belongs to descendants not yet conceived, when the closest thing to hope is not a countdown but a slow, incremental transmission of purpose from one generation to the next, passed down like a flame cupped carefully in open hands against a wind that never stops blowing? Some researchers have proposed that such missions would require not just engineering resilience but a kind of manufactured culture, an intentional mythology, rituals and stories designed deliberately to bind each generation to the mission's original meaning, lest the purpose itself erode into abstraction, into a task simply inherited rather than believed. There is a strange and tender irony here, that the same species capable of calculating orbital mechanics with exquisite precision, of designing hulls to withstand micrometeorite impacts and cosmic radiation, of engineering closed-loop life support systems that recycle water and air with unforgiving efficiency, might find its greatest vulnerability not in the mathematics of the journey but in the fragile architecture of shared belief. A ship can be built to survive collision with dust grains traveling at extraworldly velocities. It is harder to build a ship that survives the slow erosion of meaning across 200 years, across the accumulated weight of birthdays never celebrated beneath open sky, of weddings held in corridors instead of gardens, of grief experienced in rooms with no window wide enough to hold the full weight of a sunset. And yet, the historical record offers its own quiet counterarguments. Consider the Polynesian navigators, who set out across the vast unmarked Pacific in double-hulled canoes, guided only by star paths, wave patterns, the flight trajectories of seabirds, carrying with them entire ecosystems in miniature, taro shoots and breadfruit and living chickens, entire cultures compressed into vessels barely larger than a modern sailboat, journeying toward islands they could not see, trusting entirely in navigational knowledge passed down orally across generations of wayfinders. They did not know, with certainty, that land existed beyond the horizon. They sailed anyway, generation after generation, refining their knowledge, expanding their reach across thousands of miles of open ocean, because the alternative, staying fixed and unmoving, offered no path forward at all. Perhaps the interstellar arc represents simply the furthest extension of an impulse already written into the human story, the willingness to trust a horizon one cannot yet see, sustained by knowledge, by ritual, by the invisible threads of culture strong enough to survive the death of every individual who first wove them. Scientists modeling generational ships now speak seriously about population genetics, about maintaining sufficient genetic diversity across a small closed population, calculating minimum viable numbers that hover, in various proposals, somewhere between several hundred and several thousand individuals, numbers chosen not arbitrarily but through careful simulation of inbreeding depression, of the slow genetic drift that could otherwise compromise a population isolated from all outside contact. For 200 years, for 400 years, for as long as the crossing demands. The engineering considerations, layered atop the psychological and cultural ones, multiply almost beyond comprehension. Radiation shielding sufficient to protect not just the initial crew but every generation that follows, since cosmic rays do not relent, do not pause their bombardment out of respect for the passage of decades. Redundant systems within redundant systems, because a mechanical failure 200 years into a 400-year voyage cannot simply wait for resupply from a world left behind before the grandparents of those aboard were born. And beneath all of it, humming quietly beneath every calculation of thrust and trajectory and closed-loop agriculture, the question that returns again and again, patient as gravity itself: what does it mean to ask an unborn generation, one that never consented, never chose, never stood beneath open sky and decided for itself, to inherit a journey that will consume their entire lives in service of a destination they may glimpse only from a viewport, decades still ahead of them, the ship's velocity unchanged, the destination still only a brighter point among billions of others? This question, scientists and ethicists alike admit, has no clean answer, no equation that resolves the discomfort into certainty. But it is worth noting that every human being who has ever been born has, in some sense, inherited a journey not of their choosing, born into circumstances, into nations, into belief systems and family obligations and historical moments they did not select. The generational ship simply makes visible, makes literal and inescapable, a condition that has always quietly shaped human life on Earth as well, the condition of being handed a story already in progress, asked to carry it forward for a little while, then to pass it on again. Perhaps what changes, aboard such a vessel, is not the fundamental shape of the inheritance but its scale, its unrelenting visibility, the way its walls press close enough that no one aboard can forget, even briefly, that they are living inside someone else's unfinished sentence. And still, the body itself would carry its own quiet rebellion against the voyage, regardless of what the mind chose to believe. Human physiology evolved across millions of years beneath a very particular gravity, a very particular rhythm of light and dark, a magnetosphere that has, since before the first vertebrate crawled onto land, deflected the worst of what the sun and the greater cosmos hurl outward in every direction. Remove a body from Earth's gravity for long enough, and bones begin to lose density, calcium leaching slowly from the skeleton despite rigorous exercise regimens, despite centrifugal structures designed to simulate the pull of a world left behind. Muscles, unburdened, begin to soften. The cardiovascular system, no longer working against the familiar resistance of standing, of walking, of simply existing beneath a planet's steady downward insistence, begins to redistribute itself in ways that current medicine still struggles to fully counteract even across missions lasting mere months, let alone centuries. Engineers proposing rotating habitat rings, vast wheel-shaped structures spinning to generate artificial gravity through centripetal force, offer one possible answer, a way of tricking the inner ear, the vestibular system, the long muscles of the back and legs into behaving as though Earth's pull still surrounded them. But even this solution carries its own subtler costs, its own unresolved variables. A ring too small produces a gravity gradient steep enough to cause disorientation and nausea, the difference in force between a person's head and feet becoming perceptible, uncomfortable, a persistent reminder that this gravity is manufactured, borrowed, a mathematical approximation rather than a planet's honest embrace. A ring large enough to avoid this problem requires a structure of such immense scale that its construction alone would test the very edges of material science, of orbital assembly, of humanity's current capacity to build anything permanent beyond the thin blue shell of its home atmosphere. There is something almost tender in imagining engineers, generations from now, refining these designs not for themselves but for descendants they will never meet, adjusting a ring's radius by some incremental measure because a simulation suggests it will ease the vertigo of a child not yet born, will spare some future grandmother the disorientation of standing too quickly after a long sleep. This is what deep time asks of a species, not heroism in a single decisive moment, but 1,000 small acts of care extended toward people who exist, for now, only as probability, only as the statistical certainty that if the ship survives, if the systems hold, someone will eventually be born who will benefit from a choice made centuries before their first breath. Radiation remains, perhaps, the most unforgiving of all these challenges, the most difficult to soften through careful engineering or generational patience. Beyond the shelter of Earth's magnetic field, beyond the thick cushion of atmosphere that absorbs and scatters so much of what arrives from the sun and from the deeper reaches of the galaxy, cosmic rays move through space largely uninterrupted, high-energy particles capable of tearing through shielding, through flesh, through the delicate double helix coiled inside every living cell aboard. Astronauts aboard the International Space Station, protected still by low Earth orbit's partial shielding, already absorb radiation doses significantly higher than those living safely beneath the atmosphere below them. A voyage lasting decades, lasting centuries, moving entirely beyond even that partial protection, would expose every generation aboard to a slow, cumulative bombardment, an increased lifetime risk of cancer, of cellular damage accumulating quietly across a lifetime spent inside walls that no amount of aluminum or polyethylene or water-based shielding can fully render safe. Some proposals suggest burying living quarters deep within a ship's mass, surrounding the most vulnerable spaces, the nurseries, the medical bays, the sleeping quarters where children first open their eyes to artificial starlight, with the densest possible shielding, water tanks, stored ice, even the ship's own waste converted into radiation-absorbing mass. Every gram of protection, though, adds weight, adds fuel requirements, adds complexity to a system already balanced on the narrowest of margins. And so engineers are left calculating, endlessly, the precise threshold where safety and feasibility meet, aware that whatever number they choose will determine, in some small percentage, how many. Children born aboard that ship will one day develop illnesses traceable, if anyone bothers to trace them, back to a decision made by engineers who died long before those children existed, a decision balanced not on certainty but on probability, on the quiet mathematics of acceptable risk stretched across an unimaginable span of time. It is worth pausing here, in the stillness of this thought, to consider what it might feel like to live inside such calculated uncertainty, not as an astronaut trained for it, not as a volunteer who chose the risk with open eyes, but simply as someone born into it, the way a person on Earth is born into a particular climate, a particular soil, a particular quality of air. The generational travelers would not experience their radiation exposure as a countdown or a crisis. It would simply be the texture of their world, invisible, cumulative, folded quietly into the background hum of daily life alongside meal schedules and maintenance rotations and the soft mechanical breathing of a ship that never truly falls silent. There is a particular kind of courage, perhaps, in living well inside a risk one did not choose and cannot escape, the same quiet courage already practiced by people on Earth who live near fault lines, near floodplains, beneath skies thinned by pollution, who wake each day and tend gardens and raise children and fall in love inside circumstances shaped by forces far larger than any single life. And yet, for all these sobering constraints, scientists studying long-duration space travel have not abandoned the possibility, have not concluded that the challenges render the journey impossible, only that they render it demanding in ways that require honesty rather than romanticism. NASA's own research into closed ecological systems, drawing on decades of data from Biosphere 2, from the International Space Station's recycling architecture, from smaller experimental habitats designed to test how long a sealed environment can sustain human life without outside replenishment, has revealed both the fragility and the surprising resilience of engineered ecosystems. Biosphere 2, sealed in the Arizona desert in the early 1990s, demonstrated dramatic instabilities, oxygen levels dropping unexpectedly, carbon dioxide fluctuating in ways researchers had not fully anticipated, a stark reminder that recreating Earth's atmospheric balance within an enclosed structure involves complexities that resist easy prediction, feedback loops within feedback loops. The same intricate choreography that took the actual Earth nearly 4 billion years of gradual, iterative refinement to achieve. But failure, in this context, has never meant impossibility so much as incompleteness, the recognition that each attempt reveals another variable, another interdependency previously unaccounted for. Every closed system experiment since has incorporated these lessons, layering redundancy atop redundancy, diversifying the biological components of artificial ecosystems so that no single failure point can unravel the whole. Algae bioreactors converting carbon dioxide back into oxygen. Hydroponic gardens growing not only food but psychological comfort, the simple, undervalued relief of green growing things inside a metal world. Microbial communities carefully cultivated to process waste, to maintain the delicate chemical balance of soil substitutes, to perform, in miniature, the same quiet labor that fungi and bacteria have performed across Earth's surface for longer than complex life itself has existed. There is something quietly moving in this, the idea that a starship bound for another sun would need to carry not just human beings but an entire miniaturized biosphere, a compressed inheritance of 4 billion years of evolutionary partnership between organisms too small to see and the visible world they make possible. The travelers would not journey alone. They would carry with them the bacteria that populate human digestive systems, the fungi that break down waste into usable nutrients, the insects that might pollinate on-board crops, the careful genetic libraries of seeds selected for their nutritional density and their resilience to the subtly altered conditions of shipboard agriculture, altered light spectrums, altered gravity, altered atmospheric composition calibrated as closely as possible to the world every one of these organisms evolved to expect. In this sense, the generational ship becomes something more than a vehicle. It becomes a kind of ark in the oldest sense of that word, not merely a shelter from catastrophe, but a vessel carrying forward the accumulated inheritance of an entire living planet, condensed and miniaturized, sealed inside walls thin enough to traverse the vacuum, yet somehow vast enough to hold, however imperfectly, an echo of Earth's own intricate abundance. Every meal eaten aboard such a ship would represent an unbroken chain stretching back to photosynthesis first evolving in ancient oceans, to the slow greening of continents, to millennia of agricultural refinement, all of it compressed, distilled, carried forward into the dark between stars by descendants of the very species that first learned to plant seeds in soil and wait, with patience indistinguishable from faith, for something green to rise. Still, questions remain, unresolved and perhaps unresolvable in any complete sense, about whether an artificial ecosystem, however carefully engineered, however thoroughly modeled and tested and refined across generations of iteration, could truly sustain itself indefinitely, whether some subtle imbalance might accumulate. Slowly across decades, invisible until the moment it becomes undeniable, a single species of bacteria outcompeting another, a trace mineral depleting faster than its replenishment cycle can account for, some quiet cascading failure that begins not with alarm but with the smallest of anomalies, a crop yielding slightly less than expected, an air filter working slightly harder than its specifications suggest it should. Ecologists studying closed systems speak of this as the challenge of the unmodeled variable, the recognition that any system complex enough to sustain human life will always contain interactions too subtle, too numerous, too deeply layered to be fully anticipated in advance, no matter how sophisticated the simulation, no matter how many decades of data inform the design. This is, in a sense, the same uncertainty that shadows every living system, including the one that gave rise to human beings in the first place. Earth itself is a closed loop, spinning through the vacuum with its atmosphere held close by gravity alone, its water cycling endlessly between ocean and cloud and rain and river, its carbon moving through rock and root and reef across timescales too vast for any single life to witness. The difference, of course, is scale, and the forgiving margin that scale provides. Earth's biosphere, spanning an entire planet, carries redundancy built into its very vastness, a resilience born of size, of diversity, of 4 billion years spent absorbing shocks, asteroid impacts, volcanic winters, mass extinctions, and finding, each time, some pathway back toward equilibrium, however different that equilibrium might look from what came before. A ship, however large, however carefully designed, remains small by comparison, a single fragile experiment without the deep redundancy of a whole world's accumulated resilience behind it. And so the question becomes not simply whether such a system could be built, but whether it could be built with enough humility, enough built-in tolerance for its own eventual imperfection, enough capacity for correction across generations who would need to notice small deviations long before they became catastrophic ones. This, perhaps, is where the human element returns most forcefully to the center of the story, not as passengers to be kept alive by the machine, but as active stewards whose observational patience, whose willingness to notice and adjust and repair across centuries, becomes as essential to the mission's survival as any physical system of filtration or shielding or hydroponics. The ship would require not just engineers but generations of careful watchers, individuals trained from childhood to read the subtle signs of imbalance the way a farmer reads soil, the way a sailor reads weather, an inherited vigilance passed down not as burden but as identity, as the very meaning of what it means to belong to such a voyage. Some researchers modeling these long-duration missions have begun to speak less about engineering solutions alone and more about what they call adaptive culture, the idea that the ship's greatest safeguard might not be any single technology but the community's own evolving relationship to uncertainty itself, a culture built to expect small failures, to catch them early, to treat maintenance not as a chore but as a sacred and unbroken rhythm binding each generation to the next. In this framing, the true infrastructure of survival becomes almost indistinguishable from ritual, daily observation transformed into something closer to devotion, a quiet, unglamorous vigilance repeated across thousands of individual lifetimes, each one contributing some small, faithful act of attention toward a whole none of them will ever see completed. There is a strange beauty in imagining this, generation after generation waking inside the soft hum of recycled air, tending gardens grown from seeds their ancestors carried out of Earth's gravity, checking instruments calibrated by hands centuries gone, watching numbers on a screen the way their forebears once watched clouds gather on a horizon, reading meaning into patterns too subtle for any one lifetime to fully interpret alone. And somewhere outside the hull, unseen, unfelt, the universe would continue its own indifferent unfolding, stars living and dying on timescales that render even a 400-year voyage a mere flicker, a single held breath in the long exhale of cosmic time. The travelers, sealed within their careful, humming world, would carry forward not just biological survival but something more fragile and more remarkable still, the continuity of attention itself, the unbroken thread of care stretched taut across centuries, refusing to fray even as the destination remained, for every single person aboard except perhaps the very last generation, a mathematical certainty rather than a lived experience. It is this, perhaps, more than any technological achievement, that would determine whether such a voyage could succeed, not the strength of the hull or the efficiency of the recycling systems or the precision of the shielding, but the durability of meaning itself, passed hand to hand across generations like a flame carried through wind, each bearer trusting that somewhere ahead, beyond their own lifetime, someone would step out into light that no one now living had ever seen, and would remember them for having made that stepping possible. Consider what it would mean to hold such a trust. Not faith in the way that word is often used, not a belief without evidence, but something closer to the quiet confidence of a bridge builder who will never cross the span they are constructing, who tightens each bolt knowing their hands will not be the hands that feel the vibration of the first car passing over. Every generation aboard such a vessel would be, in this sense, a nation of bridge builders, laying down days like planks across an abyss of time, trusting the engineering of those who came before and extending that same trust forward into hands not yet born. There is something almost unbearably tender in this image, this passing of an unlit torch through centuries of darkness, each carrier warmed only by the knowledge that the flame still exists, that it has not gone out, that somewhere ahead it will finally illuminate a shore. And the ship itself, if we allow ourselves to imagine its physical form drifting through the void, would be a small miracle of closed-loop persistence, a self-contained biosphere no larger than a modest asteroid, spinning perhaps to manufacture the illusion of gravity, its outer shell facing a radiation environment far harsher than anything experienced on Earth's surface. Cosmic rays, those high-energy particles born in the shock waves of ancient supernovae or flung from the churning magnetic storms of distant galactic nuclei, would ceaselessly bombard the hull, a slow erosive rain falling not from the sky but from the whole of space itself. Engineers would need to think not in years but in centuries, shielding not just against acute radiation events but against the patient, cumulative damage that space inflicts on living tissue and unshielded electronics alike, water and polyethylene layered thick around living quarters, perhaps even the mass of stored ice and waste repurposed as a barrier between the fragile human body and the sleeting particles of interstellar space. Inside, the ecology would need to be more forgiving than nature ever demands on Earth, because on Earth, when one species fails, 1,000 others remain to fill the gap, an entire planetary biosphere absorbing the shock. Aboard a generation ship, the biosphere would be achingly small, a few carefully chosen algae and crop species, insects for pollination, perhaps fish in recirculating tanks, bacteria doing the invisible work of breaking down waste into usable nutrients again. Every failure would ripple outward with a violence unknown to planetary ecosystems, and so the travelers would become, whether they wished it or not, gardeners of extraordinary vigilance, custodians of a world so reduced in scale that a single mismanaged crop cycle could mean hunger 3 years hence, a single unnoticed genetic bottleneck in the algae tanks could mean the slow suffocation of an atmosphere. This is why some who study the mathematics of such voyages return again and again to genetic diversity as the quiet, unglamorous hero of the story, more vital in its way than any single technological breakthrough. A population too small would drift, through the blind arithmetic of inbreeding, toward fragility, toward susceptibility to disease, toward diminished fertility across generations. Estimates for a viable founding population vary, some models suggesting numbers in the low thousands, others arguing for tens of thousands to preserve enough genetic breadth across 4 centuries and roughly 20 human generations. The number itself is less important than what it reveals, that survival at these scales of time is not merely an engineering problem but a demographic one, a question of blood and inheritance as much as steel and silicon, a question of how many different hands are needed to keep a flame from guttering in the wind of centuries. And there would be, we must imagine, moments of profound stillness aboard such a vessel, moments when someone might press a palm against the cool curve of the outer wall and try to feel, through inches of shielding and vacuum beyond, the presence of the stars they were moving toward and the star they had left behind. Sol, that ordinary yellow furnace that had warmed every ancestor back to the first stirring of life in Earth's oceans, would recede behind them not as a dramatic vanishing but as a slow, almost imperceptible dimming, one point of light among billions, indistinguishable after a certain distance from any other star in the sky. There is a peculiar grief in this, a grief perhaps felt most acutely not by the first generation, who at least remember the blue marble with their own eyes, but by the second and third, who would know Earth only as a story, a photograph preserved in the ship's archives, a place their grandparents spoke of with a longing too vast for children to fully understand. By the 4th or 5th generation, something curious might happen to the very idea of home. It would begin to detach from any single point in space, becoming instead a quality of relationship, a texture of belonging built from the ship's corridors and the particular slant of light through its windows and the voices of people who had never known any other world. Home, for them, would not be a place at all. It would be the ship's hum itself, and somewhere ahead of them, unknown and unseen. A destination that existed for them only as an abstraction, a number on a screen, a promise inherited rather than chosen. And perhaps this is the quiet paradox at the heart of every generation ship, that the ones who benefit most from arrival will be the ones who sacrificed least for it, while the ones who bore the heaviest weight of the journey, the founding generation who chose to leave, who felt Earth's gravity for the last time in their bones, who watched the blue world shrink to a point of light and understood exactly what was being given up, would never see the shore their sacrifice was building. There is no way to make this arithmetic feel fair, because it is not fair, not in any sense that human intuition recognizes as just. It is simply the shape that time takes when a journey outlasts a life. The philosophers who have turned their attention to such questions speak of intergenerational ethics, of what obligations the living owe the unborn, but aboard a starship these questions would not remain abstract for long. They would become the very grammar of daily existence, embedded in every decision about resource allocation, every choice about which skills to teach the children, every quiet negotiation between the desires of those now breathing and the needs of those not yet conceived. Consider, too, the strange psychological whether such a voyage would generate, the particular texture of living inside a horizon that never changes. On Earth, even in the depths of winter, there is the promise of spring, the visible arc of a year completing itself and beginning again, a rhythm the human mind evolved to expect and to find comfort within. Aboard a ship crossing the dark for 4 centuries, no such seasonal promise would exist, only the ship's own manufactured cycles of light and dark, meal and rest, work and study, a rhythm entirely authored by human hands rather than planetary mechanics. Some researchers who study long-duration spaceflight, drawing on the more modest but still illuminating data from months-long stays aboard the International Space Station, have noted how profoundly the absence of natural light cycles and horizon lines can unsettle the deep, ancient parts of the human nervous system, structures shaped by millions of years of sunrise and sunset, tide and season. A 400-year voyage would need to solve this not once but continuously, generation after generation, engineering not just air and water and food, but the far more elusive resource of psychological stability, manufacturing a convincing enough illusion of natural rhythm that the mind does not slowly fray under the strangeness of true enclosure. And there is the matter of purpose itself, which sounds almost too soft a word for what would actually be required, a philosophical infrastructure as carefully maintained as any physical system aboard the ship. Human beings, across every culture and every era studied, seem to require some sense of meaningful trajectory, some story that makes sense of suffering and effort, some framework within which today's labor connects to tomorrow's harvest. For most of human history, this story has been told in relatively short arcs, a single lifetime, a single generation's hopes for its children, occasionally a multi-generational project like the building of a cathedral, which might take a century to complete, long enough that its beginning and its finishing were separated by many human lifespans. A generation ship would need to sustain this kind of narrative coherence not for 1 century but for 4, an unbroken story repeated and reinforced across 20 generations, each one needing to feel, in some deep and motivating way, that their labor mattered, that they were not merely killing time in a metal tube between 2 points in the void, but were active participants in something vast and worthy of their brief portion of it. Some who have written about these voyages imagine elaborate rituals evolving to sustain this sense of purpose, ceremonies marking not birthdays or seasons but distance traveled, perhaps, or fractions of the journey completed, a calendar reoriented entirely around the ship's slow crawl across the light years rather than around any planetary rhythm. Children might learn, alongside their reading and their mathematics, the names and stories of the ship's founders, not as dry history but as living inheritance, a way of understanding themselves as part of an unbroken chain rather than as isolated individuals adrift in an incomprehensibly long journey. Art, too, would likely flourish in unexpected ways, Because art has always been one of the primary mechanisms by which humans make meaning out of time, out of loss, out of distances too vast for ordinary language to hold. There might be songs sung only once a decade, tied to milestones of the voyage, murals added to slowly over centuries, each generation contributing its own layer to an artwork that no single person would ever see completed, in much the same way that no single person would see the voyage completed, the incompleteness itself becoming, perhaps, a kind of shared spiritual practice. And beneath all of this, threading through the generations like groundwater beneath a landscape, there would remain the simple, stubborn fact of biology, the beating of ordinary hearts, the growing of ordinary children, the aging of ordinary parents, all of it continuing inside a vessel moving through a void so profound that the nearest star system, Proxima Centauri, glimmering faintly in the black at just over 4 light-years distant, would represent not a quick errand but the entire span of a life, from cradle to grave, and further still, into the cradle of another life entirely. 4 light-years does not sound, spoken aloud, like a great distance. It is a small number, the kind of figure a child could hold in memory without strain. But number and meaning diverge sharply here, because a light-year is not a unit that the human body or the human imagination was ever built to comprehend intuitively. It is the distance light itself travels in a year, moving at nearly 6 trillion miles annually, and even at such almost incomprehensible speed, it would take that light 4 years merely to cross the gap between our sun and its nearest stellar neighbor. A ship traveling at even a significant fraction of the speed of light, say 10 or 20%, still bound by the hard limits of physics and the punishing energy requirements of acceleration and deceleration across such a voyage, would need decades at minimum for such a crossing under the most optimistic engineering assumptions, and centuries under the more conservative and perhaps more honest ones. It is worth pausing here, in the hush of this thought, to feel the actual weight of that number, 4 light-years, not as an abstraction but as a felt distance. If we imagine the sun as a grain of sand resting in an open palm, then on that same scale, Proxima Centauri would be another grain of sand roughly 10 miles away, and between those 2 grains would stretch a vast, achingly empty darkness, occasionally interrupted by nothing at all, no other star, no planet, no comet, only the thin scattered whisper of interstellar hydrogen and the occasional wandering photon, ancient light from galaxies so distant their source stars had died long before Earth itself had cooled from molten rock into something capable of holding an ocean. This is the space through which a generation ship would travel, this profound and nearly total emptiness, this silence so complete that human language struggles even to describe it accurately, because every word we possess for silence or emptiness was forged in a world saturated with sound, with air, with a constant low hum of a living planet turning beneath a sheltering sky. And perhaps this is where the true psychological weight of interstellar travel would settle most heavily, not in the fear of catastrophic failure, though that fear would surely exist in some quiet corner of every traveler's mind, but in the slow, accumulating awareness of scale, the dawning comprehension, generation after generation, of just how small the ship truly was against the backdrop of what it moved through. A single human life, lived entirely within those metal walls, would occupy a sliver of time so thin against the 400-year voyage that it would scarcely register on any but the most personal scale, and that 400-year voyage itself would occupy a sliver of time so thin against the age of the universe, some 13.8 billion years by the most careful current measurements, that it would scarcely register at all. A flicker within a flicker within a flicker, awareness, folding in on itself like a hall of mirrors extending toward a vanishing point the mind cannot quite hold steady. And yet, and this seems important to say slowly, to let settle fully before moving on, smallness on this scale is not the same as insignificance. The universe does not require permanence to grant meaning, and the briefest flicker of attention, of care, of deliberate action taken toward some chosen end, carries a weight that has nothing to do with its duration against cosmic time. A flower blooms for perhaps 2 weeks, and this brevity does not render its blooming meaningless, does not make the bee's visit to it, or the seed it eventually produces, any less real or any less consequential within the small world where that flower exists. Perhaps the generation ship, and the centuries of human striving it would represent, deserves to be understood in something like this way, not as a doomed gesture against the indifference of a vast universe, but as a bloom, brief by cosmic measure, extraordinary by any measure that actually matters, a flowering of attention and care and purpose sustained deliberately across 400 years by beings who evolved to expect meaning only within the compass of a single lifetime, and who, nonetheless, generation after generation, chose to extend that meaning outward, refusing to let the difficulty of the timescale excuse them from the labor of caring. There is, too, something worth considering in what such a voyage would teach us, should it ever actually occur, about the deep architecture of human resilience, about capacities we do not yet fully understand because we have never had cause to test them at such scale. We know, from the historical record, that human communities have sustained complex cultural and technical knowledge across centuries under far less controlled circumstances, monastic traditions preserving texts through centuries of upheaval, indigenous communities maintaining ecological knowledge across dozens of generations through oral tradition alone, agricultural civilizations refining irrigation systems over spans of time that dwarf any single ruler's reign. What a generation ship would demand is not something entirely without precedent, but something concentrated, distilled, stripped of the redundancy and slack that terrestrial civilizations have always enjoyed, a closed system with no margin for the kind of forgetting that terrestrial societies can absorb without collapse, no neighboring culture to relearn a lost technique from, no wilderness to retreat into and rebuild slowly across fallow centuries. Every skill, every fragment of knowledge required to keep the ship systems functioning would need to be actively, continuously transmitted, not preserved in the passive way a book sits on a shelf waiting to be read, but kept alive in the same way a language is kept alive, spoken daily, practiced daily, carried in the body and not merely the mind, because knowledge that exists only in theory, untested by generations of hands actually turning the valves and calibrating the instruments, has a way of quietly decaying into something that only resembles understanding without possessing its substance. This is perhaps why some who have studied the sociology of long-duration isolation, drawing lessons from Antarctic research stations, from submarine crews sealed beneath the ocean for months at a stretch, from the tightly bound communities of early polar expeditions, suggest that the technical challenges of interstellar travel, formidable as they are, may ultimately prove more tractable than the human ones. Metal fatigue can be modeled. Radiation shielding can be calculated with increasing precision as our understanding of materials science advances. But the fidelity of cultural transmission across 20 generations, the maintenance of shared purpose and mutual trust among people who will never meet the ones whose sacrifices made their existence possible, who will never meet the ones whose efforts will make possible a destination they themselves may not live to see, this remains an open question, untested by anything in the whole of human experience, because nothing in the whole of human experience has ever demanded quite this particular combination of total isolation and total interdependence sustained across such staggering spans of time. And so we return, as we so often do in contemplating these vast questions, to the body itself, to the strange miracle of a species evolved on the surface of one particular planet, shaped by its particular gravity, its particular rhythm of light and dark, its particular chemistry of air and water, finding within itself the audacity to imagine carrying that fragile inheritance across the black gulf between stars. The human body was not designed, in any engineering sense, for this. Our bones lose density in the absence of Earth's steady gravitational pull, a slow demineralization that researchers aboard the International Space Station have measured carefully across missions lasting mere months, extrapolating with some unease what such loss might mean across years, across a lifetime, across the multiple lifetimes a true interstellar voyage would require. Our immune systems, calibrated over hundreds of thousands of years to the particular microbial world of Earth, behave strangely in the sealed and sterile environments of spacecraft, sometimes growing overactive, sometimes growing sluggish, in ways scientists are still working to fully understand. Our eyes, adapted to a world with a stable horizon and consistent gravitational orientation, can suffer from shifts in fluid pressure in microgravity that alter vision, sometimes permanently. A true generation ship would almost certainly need rotational gravity, some engineered approximation of the pull we evolved beneath, spinning slowly enough to avoid disorienting its inhabitants while still providing enough centripetal force to keep bones dense and fluids properly distributed. And even this solution, elegant as it is in principle, introduces its own complexities, its own points of potential mechanical failure that would need to be sustained, repaired, and eventually entirely rebuilt using only the materials and knowledge carried aboard from the very beginning. There is something almost sacred in contemplating the sheer thoroughness such a project would demand, the way it would require humanity to essentially rebuild, in miniature and in isolation, everything a planet provides invisibly and without being asked. Earth filters cosmic radiation through a magnetic field we rarely think about and almost never thank. Earth recycles water through a hydrological cycle refined over billions of years, evaporation and condensation and precipitation moving in patterns so vast and so reliable that we mistake them for permanent features of reality rather than the ongoing, dynamic processes they actually are. Earth converts sunlight into food through photosynthesis, occurring across a canvas of forests and oceans and grasslands so immense that a single ship's algae tanks and hydroponic gardens would need to somehow approximate, in miniature, a service performed elsewhere by an entire biosphere the size of a planet. To build a generation ship is, in some sense, to attempt the construction of a small, artificial Earth, stripped of every redundancy, every buffer, every accident of scale that makes the real Earth so remarkably, if precariously, self-sustaining. And perhaps this is the final, quiet lesson embedded within the very idea of such a voyage, a lesson that requires no launch date, no completed spacecraft, no crossing of any actual light year to already begin teaching us something. The contemplation itself, the careful accounting of everything a starship would need to carry, to replicate, to sustain across centuries in the void, reveals with unusual clarity everything Earth already does for us, quietly, ceaselessly, without our asking or our thanks. It reveals the staggering complexity hidden inside what feels, from the vantage of a single ordinary morning, entirely unremarkable, the simple fact of breathable air, drinkable water, food growing quietly from soil built over millennia, a magnetic field wrapping the planet in invisible protection, a moon whose gravity stabilizes the tilt that gives us seasons, a sun burning at precisely the distance and precisely the intensity required for liquid water to exist on a rocky surface at all. None of this was engineered. None of this was chosen. It simply arrived, through billions of years of patient cosmic accident, and we were born into the middle of it, inheritors of a fortune so vast and so complete that it took the imagining of an escape from it, a 400-year voyage into the dark, to make its true dimensions visible. Perhaps this is why so many who study the question of interstellar travel, who run the numbers on radiation shielding and closed-loop agriculture and genetic diversity across 20 generations, arrive eventually at something that sounds less like engineering and more like reverence. Not reverence in the religious sense, necessarily, though for some it takes that shape, but reverence in the older sense, an attentiveness to something larger than oneself, a recognition of scale that reorders what feels urgent and what feels trivial. To spend long enough contemplating what it would take to keep a small, sealed world alive across 4 centuries of open space is to return to this world, our actual world, with eyes changed by the exercise, newly capable of seeing the ordinary miracle of a functioning atmosphere, a stable climate, an ecosystem so richly redundant that the failure of any single species rarely threatens the whole. We do not build these things. We are simply born inside them, the way a child is born inside a house built by hands long since turned to dust, never quite realizing, until they try to build such a house themselves, how many small and invisible decisions went into keeping the walls standing and the roof intact. And so the generation ship, whether it is ever built or remains forever a thought experiment turning slowly in the minds of scientists and dreamers, performs a kind of quiet service simply by being imagined in such detail. It asks us to hold, all at once, both the fragility and the audacity of our species, the fragility that makes such a voyage almost unbearably difficult to sustain, and the audacity that makes us capable of contemplating it at all, of drawing up blueprints for closed ecosystems and radiation shielding and multigenerational governance structures, of asking not whether we could survive 400 years in the dark between stars, but how, precisely, such survival might be engineered, generation by generation, decision by decision, across a span of time longer than the whole of recorded human civilization since the first cities rose along the Tigris and Euphrates. There is no guarantee, of course, that such a voyage will ever be attempted, and even less guarantee that it would succeed if attempted, given everything we have considered, the genetic bottlenecks, the psychological weight of unbroken enclosure, the ceaseless demands of maintaining technical knowledge across generations who will never see the destination their labor serves. And yet the very act of imagining it carefully, of taking seriously the full weight of its difficulty rather than romanticizing it into an easy triumph of human ingenuity, seems to carry its own value, independent of whether the ship ever leaves the ground. It teaches patience with timescales the human mind was never built to hold naturally. It teaches humility before the sheer scale of what a single planet provides without asking anything in return. It teaches, perhaps most quietly and most importantly, something about what it actually means to care for something beyond the horizon of one's own lifetime, a practice that turns out to be needed here on Earth as urgently as it would be needed aboard any vessel bound for Proxima Centauri, because the climate systems we depend upon, the ecosystems we are slowly reshaping through our own choices, the technologies we are building and the institutions we are strengthening or neglecting, all of these unfold across timescales that outlast any single human life, demanding the same unbroken thread of attention, the same passing of care from hand to hand across generations, that any interstellar voyage would require in its purest and most concentrated form. Perhaps, in the end, this is the quiet answer to the question of how long humanity could survive in deep space, not measured only in years or centuries or the raw calculus of radiation dosage and caloric intake, but measured in something less quantifiable and more essential, the durability of care itself, the willingness of one generation to labor faithfully toward a horizon it will never personally reach, trusting that the ones who follow will carry the flame forward in turn. Whether that flame is carried across the dark gulf between stars or simply across the more familiar, more immediate distance between now and whatever future we are, each of us, quietly building here on Earth, the lesson seems to hold steady, unchanged by the scale of the journey. We are, all of us, already generations aboard a vessel moving through vast and largely empty space, tending gardens grown from seeds our ancestors carried forward, watching numbers on screens the way our forebears once watched the sky, hoping, in the end, that the thread does not break, that the flame does not go out, that somewhere ahead, someone will remember why we carried it at all.